Okay, this is a video on 3.6, and I'm going to go over number 3. And, so I'll go over, get you started on 13. 13 is a long problem, but I can at least get you started on that there. So 3, this is the revenue problem. Okay, so the hockey team has a capacity of 15,000. With the ticket price set at 14, average attendance has been 9,500. And a market survey indicates that for each dollar the price is lowered, the average attendance increases by 1,000. So for example, if we lowered the price to $1,313, the attendance would be 9,500 plus 1,000. If we lowered it to $12, the attendance would be 9,500 plus 2,000, or plus 2 times 1,000. So to think about the attendance in terms of price, I think it's easier to first think about the amount lowered in terms of price. So amount the price is lowered is equal to, well, it's starting at $14 and minus the price. So that will give us how much it's lowered. So for example, if the price is now 13, it gets lowered by 14 minus 13, or gets lowered by $1. If the price is 12, the amount gets lowered by $2, and so on. So then when I want to find the attendance in terms of price, I can say, well, it's equal to the attendance right now plus 1,000 times the amount it's lowered. So for example, if it's lowered by $2, the attendance would be 9,500 plus 2,000. So in terms of revenue equals price times attendance. So if I take the equation that I have above, I can just multiply it by price. So price times 9,500 plus 1,000, this should be, 14. I didn't write 1,000, hold on. So plus 1,000, 14 minus P. All right, and let's just FOIL this out. We get 9,500 P plus 14,000 P minus, so 1,000 P times P, so minus 1,000 P squared. So putting this together, our revenue in terms of P is equal to negative 1,000 P squared plus 23,500 P. Okay, and so the next question is asking for what values of P will the revenue equal 0. So if I set the above equation equal to 0, I've got negative 1,000 P squared plus 23,500 P equal to 0. Well, I want to put this in factored form to find in this case, the x-intercept. So if I take out a P, I'm left with negative 1,000 P minus plus 23,500 equals 0. So set each equal to 0, and so either P is 0 or negative 1,000 P equals negative 23,500. So in this case, P will be 23.5. So those are the prices for which the revenue is 0. So sketch the revenue function. So this revenue function, has these two x-intercepts, opens down since A is negative, and so it's just going to open down. And this would be 23.5. Part E is then saying find the price that maximizes the revenue. Since it's a parabola that opens down, the price that maxes revenue is going to be the price or the P value, which happens to be the X value of the vertex. So the price is going to be negative b over 2a. So in this case, it's going to be negative 23,500 over 2 times negative 1,000. And this gives you $11.75. That's the price that would give us a max. Okay, so now let's skip ahead to just getting 13 started, which is just a systems of equations problems that we did. We did similar in the last unit. And so it's just a matter of keeping track of things. So the first thing that seems easy to do is using these two equations. If I simply add them, I'm going to get p squared plus p. The rs and minus rs cancel out. So you get p squared plus p equals 6. It's quadratic. How do I handle that? Well, bring everything to one side and factor. So p plus 3, p minus 2 equals 0. So the two possibilities for p are negative 3 and 2. So once you have that, we have to go down, we're going to have to go down two different paths. So let's do the case where let's see, if p is negative 3. So if p equals negative 3, then I think I'm going to work with, because now I want to solve for r and s, I think I'm going to work with these two equations. So putting into that, this first one here, putting in the fact that p is negative 3, I get negative 3 minus rs equals negative 35. Then I have negative rs equals, bringing over the negative 3, I get negative 32. And so, or I could say rs equals 32. And now when I do, now let's use this r plus s equals 13. So I can say that, let's do r equals 13 minus s. And I can plug that in for r up above. So 13 minus s times s equals 32. Or 13s minus s squared equals 32, and it looks like I've got a quadratic here. So let's bring everything to one side. I like when the leading term is positive. So s squared minus 13s plus 32 equals 0. And let's see if we can solve for s here. Okay, wait a second. I see what I just did. Couldn't even read let me go back here for a second. That's negative 33, not negative 35. Okay, so let's just correct this for a second. Where is it? Okay, sorry, just a little boo-boo there. So this is negative 33. So when I add 3, I get negative 30. So rs equals 30. Okay, sorry about that. And this will just make it so much nicer for us. Okay, so now I was wondering why it wasn't working out as I wanted it to. So s minus 10, s minus 3. So we get, when p is negative 3, I've got s equals 10. And s equals 3. So far, this is just for p equals negative 3. I've got negative 3. I don't have the r yet, but I have the s as 10. And then another point, I have negative 3. Don't have the r yet, and I have s as 3. So again, let's go back to the relationship between r and s. If s is 10, then r is 3. All right. And if s is 3, so r equals 13 minus 3, then, if s is 3, then r is 13 minus 3, or 10. There we go. Okay, so those were the points that I got when p equals negative 3. You're going to do the same process when p equals 2. I'm just going to tell you that the answers aren't going to be as pretty, though. You're going to have to use the quadratic formula. But give that a go.